And hello and welcome everyone to this OpenFOAM video. Today we're going to talk about the next thing on the list. So far we have been making our heat exchanger work in Salome, and based on various experimentation, we roughly know how to do a tetrahedral mesh with this boundary layers here. Okay, if you ever want to see what your mesh looks like on the inside, you can use this thing called a clip plot, as you can see here. So I'm going to delete this one, and okay, I'm going to delete this one. You see the clipping. Okay, delete, apply. Okay, so normally your mesh will be as such, and you can see the boundary layers there, but you want to of course cut it in half. So right click in Salome, right click, and make sure you go to the clipping spot. Okay, clipping spot, or the clipping mesh interface, where it says change clipping. Of course you will not have any planes, so you can't see anything, you can't see any cross section, but to see a clip plot is basically to see the cross section. So you can use a new absolute clip, and you can just do auto apply here, and you just press apply. You see where the plot is. Of course, if you want your clip plot to be like parallel to the X, Y, or Z axis, you can do so. Like you do parallel to the YZ, XY, or ZX. Okay. So that's how you do it. If you want to have a custom angle, of course you can do something like this. You can change your angle, and thereby you will see the clips. Of course, my preferred, of course, is to do alright. My preferred way is of course to do this parallel, and make sure you click apply, or else there will be no changes saved. And this is your clip plot. You will be able to see the inside of your mesh, and you can see the other side is completely, you can see the outside, you can see the side here as well. So that is a clip plot for you. Okay. Next, alright, so that's basically how you sort out your mesh. And we've been dealing with a simple heat exchanger mesh, only the part where you have this heat exchanger, and we were using some boundary conditions, such as okay, we are using volumetric flow rate boundary conditions for velocity, and we can see that regardless of how we change the direction of the inlet, you can just specify a flow rate velocity based on some volumetric flow rate, and OpenFOAM will just do everything for you. Yeah, OpenFOAM will just do everything for you, and you will get whatever velocity you need. It will be a plug flow, of course, but it will be sufficient for this case. Now, but we also know that maybe cases aren't always that simple. We want to go through some other really hot topic called cyclic patches, and that's what we want to do. And what is a cyclic patch? Well, if you want to model a continuous loop, let's say if you have this part and this patch connected, so to speak, you can say that all the velocity from here, I mean, if your flow is going in the so-called clockwise direction, right? Clockwise direction, it goes from the top here to and it goes through these pipes and goes to the bottom, and then it will cycle back into this pipe. You will need something called a cyclic boundary condition. Okay, so that's what you kind of need to know how to do. Okay, you need to know how to do that. Cyclic boundary condition. We can change the stuff with change dictionary, and we'll need to alter boundary conditions again. and of course apply sort of a pressure difference across these two boundaries so as to simulate some sort of a pump. Now of course I did this this rough fanning or the sweeping of a shape for this freeCAD model. Alright, so what I did was to sweep the shape through. I did not so-called show you how this shape was made, but roughly I want to do this shape because it represents a flow loop. Okay, so if you don't want to see how I made this shape because it's kind of redundant, then you can skip this video and maybe a few more videos ahead, because I will just take some time to walk through how to make such a shape. After that, the idea is once I make this shape, then I will go to Salome. I will try to make a nice mesh out of this. Hopefully a tetrahedral mesh with some boundary layers, or a tetrahedral mesh that I can convert into a polyhedral mesh with some boundary layers. It will not be exact, but at least I'll show you the process of how it's being done, because I did told you how to do the boundary layers bit. So that again will take some time, but if you know that part, again just skip ahead. Then I will show the last part, which is how do we assign boundary conditions to these special patches over here and over here. Okay, and of course in the heat, if you are doing a heat transfer, which is not exactly in this video, you can see that yeah, the heat transfer bit, you might need a hot side and a cold side, and they can be reversed the other way around. But the idea is to, okay, I have a hot side and a cold side, and I want to see what the temperature evolution of this case is. And of course you will need to use buoyant pimple foam, not pimple foam, and you'll need to separate out the patches into hot and cold patches. So that's another topic for another time. We can take a look at some other boundary conditions as well, heat generation mechanisms, or you just use a fixed temperature. There are lots of boundary conditions to play with, but that's for another video. In another series, my heat transfer series for OpenFOAM, you can take a look in the video description. So that's roughly what I intend to do, and I hope to finish. Okay, so without further ado, I will start by showing you how I made this shape over here. Okay, so let me save this as okay, heat exchanger with piping. Okay, I'll save this as heat exchanger with piping, and let's open something we're familiar with. Okay, let's see, heat exchanger 2 maybe. Okay, not this one. Experiment 1, no. I'm trying to open the yes, this one. Okay, heat exchanger video demo. So the one with the thick piping over here. So I'll need to do a few things, alright? And again, if you're not interested in this, please skip to the next videos and you can save time. But this is just a freeCAD bit. I want to delete this refinement, and I'll start making all the planes appear again. Okay, because I need them to show. I need all of these to show. Alright, so I'll delete one of the pipes. Okay, I'll delete one of the pipes. Okay, just for reference. Of course, I could delete both pipes and then make it make the shape very square and everything, but I'm not going to do that. So I'll just delete one of the pipes. So this inlet pipe is the one I will delete. Okay, and I will just have this outlet pad, and I'll have this inlet pipe plane. Okay, so I'm just going to do it the other way around now. What I can do is I'll edit this datum, and I will make this 90 degrees because it's much easier to do with 90 degrees. Okay, but maybe I won't do 90 degrees. Okay, 0, and I will put this inlet pipe plane, the pitch to be 0, so that it will be straight this way. Okay, let's take a look at the sketch to see where it is. Okay, sketch is smack in the middle, which is where I want it. So now I have this sketch. I want to make a plane perpendicular to this sketch so that I can do this sweeping around. So I'll close this. Okay, I make everything else disappear. I just want this sketch here. I'll select this circle specifically. Select this circle, and what you can do is to make another datum plane. So select this sketch 004, which is the inlet pipe cross section. Okay, inlet pipe cross section. And what do? We can create let's use a datum plane here. So this datum plane will be fixed to sketch 004, and I want this to be the plane for pipe sweep, for the sweeping of the pipe. Okay, so what do? I have to change this to 90 degrees. Okay, so let's do this. Okay, so that's not the way I want it, so I need it to be, sort of perpendicular in the other direction. Okay, that's the wrong offset, 0. Okay, so this is what I do. I change the roll to 90 degrees, and then I will have this plane here. So once I have this plane, I can start to draw the whole thing over, the sweeping part. So let's create a sketch here. Alright, so I want it to go all the way around. So I'll need to get back to my usual practice of constraints and everything. So what I need to do is pipe sweep sketch. I'll name this sketch calling it the pipe sweep sketch. I'll make the pad disappear. Alright, and we know that this is the top, so let's begin this way. Alright, so I'll draw a line here, and I'll go to the top. Okay, I can of course delete this constraint. I'll deal with these constraints later. Okay, so this is one of them. And I can fix, of course I can fix this point to this axis just to make sure it's 90 degrees by doing this fixed point onto object. Okay, so 1, and I click this axis, I'll fix point onto the object. Why isn't it doing it? Okay, fixed point, yes, okay, good. Alright, so I have to control and click, and then I will just make, I will make the length here, I'll give or take, right? I'm not producing consistently, I'm just demonstrating 50 millimeter. Okay, 50 millimeters. Let's see whether it extrudes from the pipe from the top. So yeah, that's long enough. So let's now draw an arc to do the elbow. So the elbow will be done using the arc tool. I will use center endpoints and rim points instead of center and endpoints because it's much easier to draw. Okay, make sure you click where this little red dot thing appears so that you have a collinear thing. I'll just put roughly the shape of this arc. Draw this shape of this arc roughly, and I will apply another constraint to make this line tangential to this circle. So there's a constraint for that. So select these two, go to constraints, and you click this constraint called create a tangent constraint between two entities. Okay, so it will say that the endpoint constraint, endpoint to endpoint tangency was applied. The coincident constraint was deleted. So that's what happens. Okay, so that's good. That's part 1. Next is to make sure these two points have a fixed distance, so I'll put this distance as about 40 millimeters, so that these two points, they have this fixed distance, so it's not going anywhere. This is the only remaining degree of freedom. Okay, so next thing for us is to make sure this thing is straight, but make sure this thing is like bending 90 degrees. Okay, so there's a way to do that. Okay, first I will draw a line like so. Okay, I will delete this horizontal constraint, and this line will be able to shift as and how it pleases. But one thing we can do is to make these two lines perpendicular, and that will be the last constraint for this arc. Okay, so let's make these two lines perpendicular. Okay, and it will be able to move up and down still. Okay, so I forgot there's a tangential constraint I need to apply. So let's apply the tangential constraint again. Alright, and now I cannot move the arc around. So next, when I make this line have a fixed, when I force this line to have a fixed dimension, maybe I'll just have 200 millimeters. Then this whole sketch is now constrained fully. That's why the sketch as a whole will then turn green. So the light green indication is only applicable when your whole sketch actually is constrained, not just one single part of it turning light green at one time. It doesn't work that way. So I'm going to draw another arc here. I'm going to quickly apply the same constraints. Okay, I'm going to apply the same constraints, and I'll quickly go through it. So I'm going to again do a 40 millimeter, and let's draw a line down. Okay, let's draw this line down. One here, and go all the way down. I don't need this constraint because I want to make it perpendicular. Okay, as usual, same thing. Tangential constraint and perpendicular constraint. Okay, perpendicular constraint, and now the length constraint. Okay, 350. Okay, and one more. 1, 2, 3. And then I will quickly put the same constraints again. This constraint, the tangential lengthwise. So I'm going very fast because I assume you know some of this stuff already. And then I'll draw one more line. Okay, delete this constraint, the horizontal constraint. Now I'll just make these two. Alright, make these two perpendicular. And I'll make these two tangential. Tangential is this one. And lastly, then I will fix the length of this to maybe 150. Okay, so now the whole sketch is fixed. So I can close the sketch, and let's turn on the outlet pipe, and you will see the rough shape being formed. Doesn't have to be the exact same dimensions. I'm just trying to show you what the thing is like. Next thing I do, under part design, I'm going to do the sweeping thing. So I need to sweep a selected sketch along a path to other profiles. So first thing first, I need to, okay, I'm out of time. I'll do the sweeping and then I'll be done. So I'll select this, and then I will do the sweep sketch. Okay, sweep the sketch, and then the path to sweep along under object will be this sketch, plain pipe sweep, and then I'll press OK. Fatal error. Okay, let's try again. Okay, I need to remove this edge. Okay, byte sweep needs to be turned off. Okay. Oops. I'm adding the wrong thing. I'm adding the whole plane rather than the sketch. So let's do the sketch. Yeah, that's right. It should be the right one. Oh dear, what happened? Okay, hold on. Okay, let me try again. So I'll need to select inlet pipes cross section. I will need to select sweep sketch, and I'll need to sweep it along this. Yeah, all right. So that is it. So make sure you have the inlet pipe cross section here. The path to sweep along will be this sweeping sketch, and we'll be done. And that's it. The last thing we need to do is the refine. Under part, go to part, and under part you go to refine shapes. Okay, part, refine shapes. Okay, so I'll call this heat exchanger with pipe. So look at this. Okay, we have more or less roughly the shape I was talking about just now. I'm not really concerned about exact dimensions, but just roughly how you make the shape. Then let's port it to Salome and see what we can do about it. Thanks for watching. I'll see you guys again. Bye bye.